Hey guys, it's Mr. Schmidt here, and in this video I want to cover the answers to question 2 from set 1 of the 2019 AP Microeconomics Exam's free response section. And this question is all about utility, consumer surplus, and even some elasticity thrown in for good measure. So let's go and look at the table here, and you'll see the table repeated throughout the question so that I don't have to flip back and forth, which I know can be disorienting for some people. So the following table is a table showing Dana's marginal benefit from purchasing bottles of water and good X from a grocery store. And so the first thing that you're going to notice here is they do use the term marginal benefit instead of the term marginal utility, but they mean the exact same thing. The second thing you're going to notice here is that they do go ahead and give you marginal benefit instead of total benefit, which is nice, so you don't have to calculate that to do some of this work. And so for question A, it says, what is Dana's total benefit from purchasing 2 bottles of water and 1 unit of good X, and show your work? So for this question, we simply have to add, and give me a second here because I'm going to switch the thickness of this pen. So for question A here, we simply have to add the marginal benefits for 1 bottle of water, 2 bottles of water, and the first unit of good X. And so that's going to be 24 plus 18 for the water, and then 24 more for good X, and that's going to give us $66, and make sure you have that dollar sign. On to B. B says, assume the price of a unit of good X is $5, calculate the total consumer surplus if Dana purchases 3 units of good X, and show your work. So for this one, we need to recognize that consumer surplus is the difference between what I am willing to pay and what I actually pay. And so what I'm willing to pay is the marginal benefit. And so I'm going to add 24 plus 18 plus 12, which is my value, how much I value those 3 units of good X. And then I'm going to subtract out their price, which is 3 times 5. I bought 3 of them. They cost 5 each. And if you do this, you end up with $39, which is the value of the consumer surplus. So that's A and that's B. It's when we get to C that things get a little trickier, because this is where you have to know the utility maximization rule and be able to apply it. So for C1, well, let me read the stem for C. It says, now assume the price of a bottle of water is $3 and the price of a unit of good X is $6. Dana spends her entire budget of $30 on bottles of water and good X. Explain why Dana does not maximize her benefit when she purchases 2 bottles of water and 4 units of good X, and we need to use marginal analysis to explain our answer. And so the idea here is to remember the utility maximization rule, which says that the marginal benefit of W, in this case bottles of water, divided by the price of the bottles of water should equal the marginal benefit of good X divided by the price of good X. That should be the scenario here. Now, what we need to do for number 1 here is basically plug in what we have and see if those 2 things are equal. Because if they are, then we have a problem with this question, right? Because they shouldn't be, right? So we just need to show that they are indeed not equal here. So we know that she's going to purchase 2 bottles of water, and so she's going to get 18 marginal benefit dollars from doing that. And we know the price of a bottle of water is $3. So does that equal the marginal benefit of X at 4 units, which is 6, divided by the price of 1 unit of good X, which is also 6. And so if you simplify that down, you're going to get 6 to 1. So no, they do not equal. And that would be your answer there. So you could just show this equation show that they're not equal, and that should be sufficient. You could also write out something like, the marginal benefit per dollar spent on bottles of water does not equal the marginal benefit per dollar spent on the units of X. Again, a lot of words there, but that would work as well. For C2, they say, okay, well, if that's not the optimal combination, then what is? And so what we need to do is we need to convert these marginal benefits on both sides into marginal benefit per dollar spent, and then we can figure out which combination would work given her budget. So We know that the price of a bottle of water is $3. And so what we're going to do is we're going to take all of these prices and divide them by 3. So we have $8, and then we have 6, and then we have 4, and then we have 2, and then we have 1. So those are going to be our marginal benefit per dollar spent there. And on the other side, we can divide all of these by 6. So this is going to be $4, and then 3, and then 2, and then 1, and then half. So there's our marginal benefits or utility per dollar spent on water and then for good X. And so what we need to do is we need to notice where is the marginal benefit per dollar spent equal. And there's 3 spots where this happens, and I'll coordinate them by color. So we have one here, we have 4 and 4, and then I'll use a blue color here. Then we have one for 2 and 2, and then we have one more, which is 1 and 1. And so the question is, well, which one do I pick? Well, the answer has to do with the fact that she has only a budget of $30. And so what you have to do here is you have to look at the marginal benefit per dollar spent and then calculate how much it would cost her to buy those quantities. And if you do this, there's only one combination that equals $30 exactly, and that's going to be the combination of 2 and 2, which is going to be 4 bottles of water. And by combination of 2 and 2, I mean marginal benefit per dollar spent. So if you change those to quantities, it's 4 bottles of water and then 3 units of good X. So there would be our answer to C1 and C2. And then finally for C3, it says, okay, well now what we're going to do is we're going to change the price of a unit of good X to $3. So what's going to be the cross-price elasticity? And we have to state whether substitutes or complements and show your work. On the face of it, this doesn't seem like that bad of a question if we know the formula for cross-price elasticity of demand, which is the percent change in the quantity demanded of, in this case, water, which we'll call W, divided by the percent change in price of good X. But as you're going to see here, we don't have all the information we need in the stem of the question. We actually have to go back to the table to find one number. So on the bottom here, what we can do is we can go ahead and get our prices. So this is going to be the new price minus the old price, 3 minus 6, divided by 6, and then we multiply that result times 100. So the price part of this is not that difficult. The problem is we need to find the new quantity of water that we're going to buy. We know the old quantity, right? So we'll call the missing number W. Minus 4, remember, because from the previous question, we bought 4 bottles of water in the optimal combination. And then we divide by that old number, which is 4, and then we multiply that by 100. So the only thing we're missing here is W. Well, how do we get W? Well, hopefully, on the question, you figured out, okay, I've got to go back to the table and recalculate the marginal benefit per dollar spent on good X because the price has changed. The bottled water marginal benefit per dollar spent isn't going to change, but on good X it is. But the good news is they're going to be exactly the same because both of them now cost $3. So it's going to be 8, 6, 4, 2, and 1 on both sides. So luckily they make that calculation really easy for you. And so then what you have to do is find what is the new optimal combination. And so the first thing you're going to notice here is that, well, there's 5 different combinations here because they equal each other in 5 places. But to save this video and you a little bit of time, the optimal combination is going to be 5 and 5 because you're going to spend spend $30 exactly. 5 times 3 is 15 plus 5 times 3 is 15. So you spend $30. There you go. There's the optimal combination. And so then what we get to do is we get to change this W here to a 5. And then if you solve this, you get negative 0.5. And because it's negative, these are going to be complements. So that is all for this video going over question 2 of set 1 of the 2019 AP Microeconomics questions. Until next time, have a great day.